Hello everyone, I'm Chuanxin Lan, and I want to introduce you how to use HPC AI500. The correct release of HPC AI500 is version 2.0, which is publicly available from Bench Council HPC AI websites. The reference implementation of HPC AI500 is one of the bench hub. The general steps to run the benchmark are as follows. First, download the refreshed implements of GitHub. Second, prepare the dataset environment according README. We have packaged all the dependencies into Docker, which is more convenient for everyone to configure the environment. Third, running the scripts, including training, revolution, and inference. Correct HPC AI500 consists of computant benchmarks and macro benchmarks. The computant benchmarks includes extreme weather analysis (EWA) and image classification. Next, we start with the computant benchmark, taking EWA as the example. First of all, I will introduce some background knowledge about this workload. EWA poses a great challenge to human sources. It brings several damage to people's health and economy every single year. For instance, the headwinds in 2019 caused over 1,600 deaths, according to the UN report, and the landfall of Hurricane Flanas and Merkel cost about $14 million worth of damage to U.S. economy. In this context, understanding extreme weather life, control, and even predicting its future trend become a significant scientific goal. Achieving this goal always requires accurately identifying the weather pattern to acquire the insight of climate change based on massive climate data analysis. Traditional climate data analysis methods are built off human expertise in defining meteorite cause of extreme weather events. However, it has a major drawback. There is no common health set of criteria that can define a weather event due to the man-made subjectivism, which leads to inaccurate pattern detection. Therefore, deep learning has become another option for climate scientists. As shown in the figure, the orange weather image have been proceeded to the level 1, which is essential an object detection task. The EWA dataset is made up of 26-year climate data. The data is every year is available as one HDF5 file. You can obtain this data by this web link. Each HDF5 file contains two data sets, image and books. The image data set has 1,516 example images with 16 channels. These channels are quite different from a criminal dataset such as ImageNet, including many particle information inside of virtual information. The more details can be found in this website. The adopted model is the FastRCNN FPN version, using ResNet 15 to extract features. FastRCNN target real-time object detection as one of the last models of RCNN family. It depended the selective search used in the previous RNN version. Instead, FastRCNN proposed a distributed convolutional neural network named RPN to achieve nearly code-free region purpose. With such a design, object detection is much faster. As a result, FastRCNN wins the once place in task in RISC 15. The first running step is data processing. The implementation needs the data to be processed to cuckoo format. Therefore, we provide two scripts to do this work. The first one, HD5 to JSON, is responsible for generating JSON files of cuckoo format. The second one is responsible for generating 16-channel TRFF images. The second step is environment installation. We provide a Docker file that contains all the dependencies. User can build a Docker image based on this Docker file, and then start running this image by this command. We also provide a training script to perform distributed training. Our implementation is based on OpenMPI and Harvard. After training, we can choose a product to check the model quality. The result is shown in the screenshot. This is the screenshot. And for the metrics, we can get the time to accuracy by the script time to accuracy as shown in the figure. The time to accuracy is 16634.99 seconds. Next, we introduce how to calculate the waveforms. We get a training time and accuracy through the report time to accuracy. Then we can conclude flows by training time as the following formula. In EWA, the base size is 1, and the flops per image is 691 G flops. Finally, we can get the wave flop by the following formula. In EWA, the n is set to 10, and the target quality is set to FAP is 0.35. In addition to the time to accuracy and V-flops, we also can obtain other metrics from a test board, such as training loss and the achieved quality. We also provide a DOP for versioning the product result. The production result continues the product box and their confidence. We can show that. That's all. Thanks.